We're here with Paul Kling from Schnieder Electric Motion. Paul, the topic of laboratory automation, technologies for motion control are getting more and more critical in that area. What are some of the trends you've seen toward that end?
That's a good question. This is a heavy focus for us, is that medical lab automation, life science marketplace, and the trends we definitely see are really towards a more compact solution. They're really looking for additional control in a smaller package because the space that they're typically putting these applications and these instruments into is typically very expensive real estate. So their goal primarily is to make it smaller, faster, lower cost.
You have a demonstration of state-of-the-art equipment in that area running behind us. Can you kind of take us through that?
I sure can. So what we're looking at here is a particular instrument that's simulating a very common application in the lab automation market space. We're doing an XY positioning of a microtiter plate. Could be positioning vials or different samples, doing aspirating or dispensing or some type of testing. It's an XY system that has two integrated units, integrated MDrives that are driving the rotary motion on the ends. Again, this creates the environment for a very small package, compact package with no external components that are needed to accomplish the motion.
What kind of accuracies do applications like that require?
You know, that's great. It can be down from the millimeter size down towards the picoliter. So we do a lot of actual dispensing and pump control in this marketplace as well, and so they get into very high precision applications.
What kind of equipment does it take to do that, to realize that?
So what you'll see behind us is, again, a mechanical system that's going to be moving product around, but the key to the motion control side of it is really the actual rotary motion itself. And so what we're driving with in this marketplace is an integrated solution, which really takes the motor, drive, and control and I/O communications and packages it all in one package. And so we talked a little bit earlier about what are the goals of some of this marketplace and the trends. Well, that allows for the customers that are building these instruments to make it smaller, more compact, and really a higher control capability than they could in the past.
Well, we have some examples of motion control equipment here in front of us. Exactly what are we looking at?
So what you're looking at here is what we really target for this marketplace, which is an integrated product. And if you take a look at the solution here, this is a motor, drive, and control all built in. It has built-in I/O as well as communications and various different networking communication options. Again, the benefit here is that we're not taking several components and interfacing them together. We actually provide it in one very compact solution. These happen to be rotary solutions, so you'll be mounting these to some type of load. We also have the linear solution in an external or non-captive solution, so you can take the benefit of an integrated product with built-in linear translation.
Accuracy is important, but what about speed? How fast does something like this have to move?
You know, it varies. Because it's fully controllable and fully programmable, you can really program the positions, the velocities, and the slews that you want to accomplish, and a lot of it really depends on what you're actually moving. So there are some products where you have very high throughput when you start to get into the clinical chemistry side of it and doing sampling, and then you have ones that have certain product in there that you have to be very sensitive to the motion. The nice thing about the solution with our integrated MDrive product is that it is fully programmable, and you can compensate for whatever product you are going to be moving around.
What kind of loads do you typically have to deal with, and is there anything special about them, or are they cantilevered, or are they pretty straightforward?
You know, it varies, and that's a good question. From the demo behind us, there are some cantilevered loads, and so that depends heavily on the mechanics that you might be specifying in, and it also translates back to the size motors that you want to size in there. One of the uniqueness when you talk about loads is that with our MDrive product, we have a technology called HMT, and in essence, it takes a stepper package and turns it into the performance of a two-phase servo. So purely closed loop, variable torque, variable current, and so you get that performance benefit of a servo in the package of a stepper. And so the benefits of there is that you get this higher performance without having to go to a larger, more costly solution.